We're going to talk about the number E. All right, so no, that's not a typo. Yes, we're talking about the number E. The number E is an irrational number. We could go into how it's derived and where it comes from, but we're not going to go in. You want to?
No.
Yes. Wait, now there's going to be a bonus question.
3.141556.
Okay, so I relate it to pi. Pi is an irrational number that y'all are very familiar with. What does irrational mean?
It goes on forever.
On forever and ever, no pattern. So here you go, bonus. How do we derive pi? Where does pi come from? It does have to do with circles. Yeah.
It's got something to do with that.
The ratio of the
Circle.
the circumference of a circle to its
Diameter?
So the number E is also, and I'll just show you, because if we took this expression 1 plus 1 over n raised to the nth power, if we could plug in an infinity for n, then we would find out what the number E actually is. So what we say is E is the limit as n approaches infinity of 1 plus 1 over n to the n. In other words, if I could actually plug infinity in, I would get the value that we use for E. But because, yeah.
Can you say that whole thing again?
The bigger number you put in for E in this, okay? So let's say, I'll start small. 1 plus 1 over 5 raised to the 5th. 2.488. Okay? But let's say I changed this 5 to a, come on, to a 50. Okay? Let's say I changed that 50 to a 500. No, it won't. Actually, the number that it's approaching is 2.718. Because I just know. The closer that you get, so if you look at your calculator, if you pulled up E, so you probably have an E to the X, so you'll have to put 1 to find the value of E. The bigger I put in that number for N, the closer it gets to this value. It should be somewhere around the LN button. I have to second LN.
Do the graphic? I mean, do the sign.
It's 2 buttons above.
Yeah, it's right here.
I got it. It's 2 buttons above the on.
See it.
LN. Oh, I did.
Okay. So, knowing that, we're going to talk a little bit about E and what we do with it. Y'all ready? Okay, well, anyway, here we go. All right. So, we're going to do some operations with E. I guess I should say operations. I'm not going to spend long on this because it would be an insult to your intelligence if I did. For example, e to the 7th times e to the 4th would give you what? Yes. You treat it like any other variable. 24 e to the 5th divided by 4e squared would give you what? 6. Right? All the same properties. Do I need to spend any time on that? A time on E. E is used a lot in a lot of application problems that you will find as we hit logarithms and as we move on. So I need to show you about graphing with E. It's still growth or decay. It's still the same process. There's just an E thrown in there. So now it looks like No, I'm trying to think. I want to use a different variable. I'm going to call it C. Now, and I show you this way. Your book doesn't really use this way. It just throws you into it. But now, e to the whatever this value is makes up your b. So I want you to think about it for just a minute. And it makes sense if you think about it. What is the value of e? Approximately what? 2.718, right? If e is approximately 2.718, and I said that this could be growth or decay, how would you make it? I mean, clearly 2.718 is bigger than 1, right? How would you make it a decay?
Negative.
What's negative?
The
B can't be negative. If A is negative, it just... Good job! I think you and Ella got it about the same time. Why would the exponent make it decay? Why would a negative... It flips it over. If I had e to the negative 1, that would be 1 over e, right? Which would be less than 1. Do we all agree with that? So in this case, it's still when b is less than 1, it's decay. But to force b to be less than 1, that means when this exponent is negative, it's decay. And when it's positive, it's growth. And if it's not there, what is it? 1, because it's being multiplied. Okay, so if it's not there, it's just e is the b. E is the b and it's growth. Is that confusing? Negative. Sorry. That kind of looks like an H. So I think I'll show you an example of each, and you'll probably be good after that. Ready? No? All right. Let's say I have y equals 3e to the point. The only thing about these is the numbers are going to be nasty to work with, but other than that, yeah. Ooh, that's 0.25. So my question is it growth or decay? It's growth. It's positive exponent. It's growth, right? The exponent is 0.25x. So b in this case, the b value would be e to the 0.25. Yeah. Right. Where is the asymptote?
0.
Give me an easy point on the graph.
Negative 0.25? No, wait. 1.
0. 3. Why? You have no K, your A is 3, and you have no H. So H, A plus K would be 0, 3. Do we all see that? You can use whatever you'd like. What do you want to use? 1? If I use 1, I'm going to have to use my calculator, and I will get a decimal.
What makes...
That'd be 1/4, it'd be 4. But even as a whole number, you still got 2.718, so it's going to be gross any way you do it. So I'm going to do 3e to the 0.25. 3.85? Can everybody get 3.85 when you do that?
Wait.
Let me go back to the calculator.
3.85.
Yep, 3.85.
May I? It's mine. I bought it.
All right, so 3.85 And of course it is growth, we said. So there you go. That's terrible.
Wait, that's included.
1, 2. Oh, no, it's not. Because I just drew decay. I'm an idiot. Okay. Up. Language. There we go. Now it's growth. I graphed decay and said it was growth. All right, what's the domain here? What's the range? Yes.
Oh, so you just solved it how if you don't need to pick it.
Well, I did. I used 1. This was my first easy point. That's my HA plus K. This was my second easy point. Do you see it's the same? It's exactly the same that we were doing. There's just an E thrown in there.
Do we just exclude E?
We can't exclude
No, because when we get to logarithms. Are you going from smallest to biggest? That one, it's always from the asymptote. It's either from the asymptote up or below up to the asymptote.
I did that wrong.
All right, look at the next one, growth or decay. Why? That exponent, you see that exponent that's negative? Decay. Where's my asymptote?
I'm so freaking
Where are you confused, Palmer?
range.
You're still confused on range? Okay, let's graph this one, then I'll talk a little bit more about range. All right, give me an easy point on the graph. 2, 2. Nope. If A is negative, it's below. What easy point should we use? 3. When I plug it in, I get e to the negative 0.75. 3 minus 2 is 1. When you plug this on your calculator, what do you get? Hope it's smaller than 2 because it should be decay. Because that exponent there is negative.
No, not.
I got 1.4.
Wait, what if you put a point zero, 0.05, and then
T, I got 1.4.
I do that and then I add 1.
because 3 minus 2.
Yeah.
But I just added the 1 instead of doing after the
And it would have done right because exponents come before addition on
Yeah, I got the same
order of
thing.
operation. Yeah, 1.47. Corbin, did that answer your question? I can't remember what it was, but what did you ask? About the decay? Oh, growth and decay, before we did, yeah.
This one, you see if it's in the
No, above or below still has to do with the A that's in front. Always.
but it's,
This one's decay. This one is decay above the asymptote. Because remember, decay can go above or below. And growth can go above or below. So I've got 4 possibilities. I've got growth or decay, and then each one of those can go above or below. So the exponent, this is determining growth or decay. This is determining above or below the asymptote. When we plugged in for this point, that's the only time we really dealt with it. Like the,
If you flip it and make it 1 over.
I just put it in the calculator like that. E to the negative 0.75. You could do 1 over e to the 0.75, but I just let the calculator do it for me.
Go back to where else can you do
What's the domain? How about the range?
Wait, I thought
You thought what?
no.
You sure?
Wait,
Palmer.
why did you
Okay, I think I get it now.
Yeah. Bottom up. Always bottom up. And it's the range on these is always going from the asymptote. Not the asymptote. Tell me what you think.
Not bad. It's like the same thing. Yeah.
It is.
You just
Yes, the range. Yes, yes. Whatever this asymptote is, that's one of your points on your range. If it's above the asymptote, it'll be the first number. If it's below the asymptote, it'll be the second number. So if this was like this, right, it would be negative infinity up to 1. So it always goes from the lowest up to the highest. What else? Speak now, forever hold your peace, or at least hold it till tomorrow when we go over homework.